Well, my name is Steve Torchinsky, and I'm the project manager for the alfa project at Arecibo. Alpha stands for the Arecibo L-band Feed Array. It's a radio camera that's being built here at CSIRO in Australia. Alpha is a radio camera, and that means that we can get information from more than one point on the sky at the same time. Much like an ordinary camera works, it builds up an image with lots of little points put together, which you call pixels normally, and many people are familiar with that now because digital cameras are so popular. And this is the same thing, but it works at radio wavelengths. So the pixels detectors are much, much bigger than in an ordinary digital camera. And we build up images in radio wavelengths. But at each pixel, we have not just the intensity or the amount of light coming in, but also the amount of light at each frequency or each color within the spectrum. And that's important because the spectrum tells you what type of material is giving off that radiation. The alpha science is roughly divided into three main areas, one of which is pulsars. So we're going to do a survey of all the sky that we can see from Arecibo and just try to detect as many pulsars as possible. And the reason is because we want to find some strange pulsars, fast pulsars, binary pulsars, and all these objects are used to do tests of fundamental physics. The next area of science is galactic astronomy, and there we're basically measuring the distribution of neutral hydrogen, hydrogen atoms, or hydrogen gas, if you like, that's distributed throughout the galaxy. Some places it's more dense and some places less dense, and some places it's moving faster or moving slower. And we'll also be looking at hydrogen in external galaxies and also the space in between the galaxies. That's the third main area of science for alpha. Well, the receiver group here at Australia Telescope National Facility are well known around the world in radio astronomy for building excellent receivers. And one of the great achievements was the multi-beam receiver on the Parkes radio telescope. Well, Arecibo is the world's largest single-dish radio telescope. It's the largest reflector in the world of any kind. It's 305 meters in diameter and built right into a valley. It's quite an interesting design because it's a spherical-shaped mirror instead of the normal paraboloid. And we have a special corrector system which takes the reflections from a spherical mirror and makes it into a point focus. That's called the Gregorian dome. Well, there's a public visitor center with a beautiful view over the telescope, and when you come out onto the viewing platform, you see the whole bowl sort of dropping away from you below. It really does fill the valley. And then if you look up about 150 meters up from the ground is where this big Gregorian dome is, and inside that houses a mirror that's 22 meters in diameter. So even although it looks small compared to the rest of the dish, in fact, it's also very big. And during maintenance time, you'll see people working there. It looks like a big, huge, almost a suspension bridge. Lots of cables and this big triangle with the bowl suspended over the center. It's a beautiful sight. The Parkes telescope is 64 meters in diameter, and Arecibo is 305 meters in diameter. So it's something like 5 times bigger than Parkes. There's a lot of advantages, of course, to having a much bigger collecting area, bigger mirror. It means you're more sensitive. You can detect fainter sources. So we could see sources that are very weak in the sky, which usually means they're farther away or just not very strong. I think probably the main science in astronomy at Arecibo is studying pulsars. A lot of other work is done in the measuring of neutral hydrogen, that's hydrogen atoms floating freely in space, and that's by far the most abundant material in the universe, so it's very important to understand how it's distributed in the universe. The Arecibo Observatory is available to scientists all over the world. You don't have to be an American, and you don't have to be associated with Cornell University. Everyone can apply and send in a proposal to use the telescope. It's going to be installed up in the receiver dome at Arecibo. So it has to be moved out right underneath in the center of the big dish. And then it's hauled straight up 150 meters into the big Gregorian dome and moved over a bit sideways onto our big rotating plate, which takes all of our receivers. We currently have 8 receivers, and alpha by far will be the biggest one of the lot. In fact, the weight of alpha is 1/4 of all of the other receivers put together.